Okay, so we're doing arc measure. Okay, the central angle in a plane, an angle whose vertex is at the center of a circle. That's a central angle. So in this case, it is angle AOB is a central angle. Also angle BOC is a central angle because their vertex is at the center of the circle. Okay, an arc is a piece of the outer edge of the circle. So a minor arc is one that is less than 180 degrees. Does anyone remember how many degrees are in a circle? 360, right? All the way around a circle is 360 degrees. Okay, so it's less than half that is a minor arc. And this right here, A to B, that is the minor arc. Okay, you write it like this with two letters. And you say arc A, B. A minor arc has two letters. You use two letters when you're naming it, similar to like a line or a segment. A major arc is bigger than 180 degrees. And a major arc is named with three letters. So you know which direction you're going. So if I'm going to do a major arc, and I want it to be like this, I would label it arc A, D, B. Arc A, D, B. Not C, A, D, B. Like I said. To show that it starts at A, it goes in the direction of D, and then it ends at B. Yes. You don't need to. It is a point, but you don't need to include C. Okay? It's assumed since you go past it and end at B. Okay? Any questions over that? A semicircle then is exactly 180 degrees. It's half a circle. Can anyone name a semicircle here? Okay, you wanted three letters. ADC. Arc ADC. Again, three letters to show which direction you're going. If I just said AC, I wouldn't know if it's this one or this one. I mean, they're both semicircles, but you want to show I'm looking at this half of the circle versus the other half of the circle. Or again, you could say arc ABC is also a semicircle. Any questions over that? Okay, now we have to talk about the measure of an arc. We measure arcs like we measure angles in degrees. So the measure of an arc is in degrees. If I ask you for the measure of an arc, I'm asking for you for the degrees of it. Okay, and the minor or arcs in general are equal to the measure of the central angle. So here it talks about arc AB. Its central angle is 60. So the measure of arc AB would be 60 degrees. The same thing with BC. The measure of arc BC would equal what, class? 120, because the central angle is 120. Any questions over that? We're good? Okay. The measure of a major arc, you can do it with subtracting from 360. So the measure of ADB, so ADB would be that 60 degrees minus 360, because this is the only part that's not part of the major arc. So if I take away that 60 degrees, I'm left with the rest of the arc. Does that make sense? Okay. So now we're going to do an example of these. So here we're asked to find the measure of CD. CD measures what? Brianna, what do you think it measures? 148. The central angle is 148 degrees, so it is 148 degrees. Okay, the next one would be CDB. CDB. Any ideas on how we can find that? Danny, you think you know? Very good. 148 plus 180. Because BD is a diameter because it's a straight line that goes through the diameter, or through the center. Wait, it's a diameter because it goes through the diameter? No, it goes through the center. Okay, we add those two together. 328, is that right? Okay, then we went to the measure of BCD. BCD. Yeah? It is just 180. It's a semicircle because it started and ends on the diameter. And then find BC for me, class. Yes. Okay, class, what's the measure of BC? Arc BC? 32. Any questions over that? Okay. Let's look at the next one. Okay, I want to tell you that there are no diameters here. Even though it looks like a diameter, it is not diameters. Unless you can prove that it adds to 180, none of these are diameters. Okay, so don't add and subtract from 180. Find the missing arcs. Huh? Sure. Got that first one? We're just going to find BD, which was 42 plus 83. So that gave you 125. BF is this. It should have been 360 minus all of this other stuff, which was 223. So it's 137. Again, all of these angles add, or arcs add to 130 or to 223. And then BED, BED, the E has to come first. So you have to go this direction. So you're gonna add 137 plus 45 plus 53 to equals 235. Any questions over that? All good? Okay, the arc addition postulate is what we just were doing, adding and subtracting arcs to get the big arc. So arc BD was equal to the measure of arc BC plus the measure of arc CD. The two smaller arcs equal the bigger arc. Okay, congruent circles. Two circles are congruent if they have the same radius. Okay. The radii have to be congruent. So it'd say circle P is congruent to circle M. Now congruent arcs, two arcs are congruent arcs if they have the same measure and they are arcs of the same circle or congruent circles. So they can measure, two circles can have, or two arcs can have the same measure of like 60 degrees. But unless the circles are congruent, the arcs are not congruent. So in this, it says that this arc is congruent to this arc. That means that the radii have to be congruent as well. If the arcs were not congruent, then you couldn't say that. Okay. In this one, you have the central angle, which means the arc, the measure of the arcs are equal. But are those two circles congruent? No. Okay. So arc AB is not congruent to arc CD because the circles are not congruent. So they have to have both. Congruent circles are the same circle, because the same circle you can be congruent to yourself. Okay. And the arcs have to have the same measure. So it needs both of those. Any questions over that? Okay, 9.2 homework.